In this video, we're going to be talking about evaluating algebraic expressions. So what does that mean? Well, in algebra, you're usually given an expression, something like 3x plus 5, and you're given the value of that variable. So say our value in this case, or our variable in this case is x, so we're given the value of the variable x to be equal to, say, 2. And our goal is to evaluate this expression, which means just simplify it down to an answer. So when evaluating, the process is pretty self-explanatory. You have an expression and you have a variable and you plug that variable into the expression. So going back to our first example, which was 3x plus 5 when x equal to 2, evaluating just means taking this value of x, which in our case is 2, putting it in the place of the variable in the expression and doing the resulting math. So in our case, that's going to be plugging in 2. So we're going to do 3 times our value of x, in this case is 2, plus 5. We simplify this mathematically, so we use 3 times 2, which is 6, plus 5, and it gives us 11. So our expression evaluated to be 11 with our given variable. Of course, if you change the value of the variable, you change the value of the expression. So looking at this exact same example, say that our value for x in this case was x equals negative 2. Well, once again, we plug this value of x into our expression. So we're going to do 3 times the whole expression, which is negative 2, plus 5. 3 times negative 2 is negative 6, plus 5 gives us negative 6 plus 5, which is negative 1. So our new variable gives us a value of negative 1. Now, let's look at some problems. For problem 1, we're going to do 4x minus 1 when x equals 3. Okay, so we approach this the exact same way. We take our value of x, put it into our expression, and do the math. So if we pull this down here, we're going to do 4 times our value of x, which in this case is 3. So 4 times 3 minus 1. We simplify the math, so we do 4 times 3, which is 12, minus 1, which gives us 11. So this expression evaluated to be 11. Now, let's look at problem 2. Problem 2, we're going to do 3 times x minus 2 when x equals 5. Okay, we approach it the exact same. We take our value of x, we plug that straight into our expression. When we do that, we get 3 times 5 minus 2. Using PEMDAS, we solve inside the parentheses first, so we get 3 times the inside the parentheses, which is 5 minus 2 gives us 3. And now we do the multiplication, which is 3 times 3, which gives us 9. So this expression evaluated to 9. Now, problem 3, let's see what we're given. We're given the expression 2x plus y, where x equals 4 and y equals 1. Now, when you have more than one variable in an expression, in this case we have an x and we have a y, you solve it the exact same way. You take your value of x, you plug it into your expression. You take your value of y, you also plug that into the expression, and then you simplify. So in our case, let's see what we're going to do here. We're going to take our value of x, so 2 times our value of x, which in this case was 4, plus our value of y, which is 1. Using PEMDAS, we do the multiplication first, so we get 8 plus 1, which gives us 9. So this expression with 2 variables evaluated to 9. Now, for problem 4, we're going to do another one with 2 variables. In this case, we're going to do 3 times a plus 2 times b. And we're going to have a equal to 2 and b equal to 1. Now, the variable can be represented by any letter, any character, no matter what that may be, but the approach is still the exact same way. You take your value for a, you plug it in, take your value for b, and you plug that in. If there was an x or a y or a z or a q or a delta or a lambda, you would approach that the exact same way. So for us, we're going to do 3 times our value of a, which is 2, plus 2 times our value of b, which was 1. We simplify the math. We do the multiplication, which is 3 times 2 gives us 6, plus 2 times 1, which is 2. 6 plus 2 is equal to 8. So this expression evaluated to 8. Now, for problem 5, let's do 4m plus n squared. We have m equal to 1 and n equal to 3, or negative 3, excuse me. Okay, as always, we take our value, we plug it in. But it's important to note here that when we plug in our value of n into our given expression for n, we have to square the entire value of n. So in this case, for n specifically, when we do the arithmetic for it, it's going to be the whole value of negative 3, which was our variable, that whole value squared. This is not the same as this. And so we need to be careful about. This part, when evaluated, gives us 9. This part, when evaluated, gives us negative 9. And these two are not equal. So when you're doing these problems and you're evaluating expressions, you have to make sure that when you have squares, when you have cubes, quartics, or that's degree 4, whatever it may be, whatever function it may be, that you're taking the entire value of that variable and doing the function to it. In our case, it's pretty simple. We're going to do 4 times our value of m, which is 1, plus our value of n squared, so the whole of negative 3 squared. Using PEMDAS, we can solve this. We can get 4 plus negative 3 squared, which already is 9, and that gives us 13 as our final answer. So this expression with 2 variables evaluated to 13. Now, just to iterate again why it's so important, let's move this over here. Oh, that's not supposed to be there. Oh, technical difficulties. All right, let's move this over there, and let's do it the wrong way. So in our case, let's do it when we do it, we plug in negative 3 and don't square the whole thing. When we do this, we can do it the same way as always. We can do 4 times 1 gives us 4, minus 3 squared gives us minus 9. So our answer here becomes negative 5. This is why it's so important. These two values are not the same, which is why we have to be careful about squaring the values or using whatever function it is properly. All right, for the next 3 problems, let's write those down. We're going to do 2x plus y when x equal to 3, y equal to negative 1. Then we're going to do x plus 2 squared, where x is equal to 1. And lastly, we're going to do 4 minus x squared, where x is equal to negative 2. I want you to pause the video and try and solve these problems on your own. Let me label them. 1, 2, 3. So go ahead and pause the video and try these, and we'll solve them here in 3, 2, 1. All right, starting with problem 1. We're going to do our same approach as always. We're going to take our value of x, plug that in, and our value of y, and plug that in. Those are terrible arrows. It'll be okay. We're going to get 2 times our value of x, which is 3, plus our value of y, which is negative 1. Be careful about the negatives. We simplify this, and we get 6 plus negative 1, which is equivalent to saying 6 minus 1, which gives us 5. So the first problem evaluated to be 5. For problem 2, we're going to do x plus 2 squared. Our value of x in this case is going to be 1. So we're going to plug that in. So we're going to do 1 plus 2 squared. Evaluate inside the parentheses first using PEMDAS. That gives us 3 squared because 1 plus 2 equals 3. And then 3 squared is equal to 9. So our expression here evaluated to 9. Over for problem 3, we have 4 minus x squared where x equals negative 2. This is one of those ones where it's important to understand that our value for x here is negative. So we have to square that entire value. So let's do that. Let's plug in 4 minus the whole value of x, which is, in this case, negative 2 squared. This gives us 4 minus negative 2 squared is negative 2 times negative 2. Negative times a negative gives a positive, so this is going to be 4 minus 4, because 2 times 2 is 4. And this is going to give us 4 minus 4, which is 0. So this expression over here evaluated to be 0. This process never changes. No matter which algebraic expression you're simplifying, you're always going to take your value, you're going to plug that into your expression, and you're going to simplify. Algebra is 9 times out of 10 just careful substitution and then some math.